Hello and welcome. Here we have this challenge. It's a simple one, okay, simple exponential challenge. The question is 2 to the power of x plus 1 equal to 2 plus 2 to the power of x minus 1. What is the value of x? Here we are asked to look for the value of x. And I've solved this challenge. I discovered that at the end, we cannot actually get an exact figure that when we substitute here and here, will give us an accurate answer. So whatever we're going to have from this solving will give us an approximate value. Okay? All right, so how do we go about solving this? We first of all rewrite this expression here and also rewrite this expression here. So doing that, we are going to apply the law of indices, which says that your a to the power of your m plus n is same thing as your a to the power of your m times your a to the power of your n. Okay, so we can rewrite this and rewrite this. So this is going to give us our 2 to the power of x times our 2 to the power of 1 equal to 2 plus this will give us 2 to the power of x times 2 to the power of minus 1. Now, this is in negative power. We apply another law again, which says that your a to the power of minus m is equal to 1 all over a to the power of your m. So if we do that, we're going to have our 2 to the power of x times 2 to the power of 1 equal to 2 plus our 2 to the power of x times 1 all over 2 to the power of 1, which is same thing as 2. We have to eliminate this denominator. We multiply each of these terms here by 2 to the power of 1. And 2 to the power of 1 is 2. And so this also gives us 2, right? So we're going to have here 2 to the power of x times 2 times 2 equal to 2 times 2 plus our 2 to the power of x times 1 all over 2 times 2. And so this and this will leave. We now have this to be our 4 bracket 2 to the power of x close bracket. This is equal to 4 plus our 2 to the power of x. Easy. All right. Now what we do, we are having 2 to the power of x here. We are having 2 to the power of x here. We can do a simple substitution, but that substitution is of no value. In other words, as I said, let 2 to the power of x represent a different alphabet, but that is meaningless or baseless. And so we move this quantity to this side. Here we have a plus, and when it crosses the sign of equality, it turns to minus. And so we're going to have our 4 bracket 2 to the power of x close bracket minus 2 to the power of x equal to R4. This is just a bracket. This bracket here also means multiplication. So this could be written as your 4 times your 2 to the power of x minus 2 to the power of x equal to 4. Now, something is common to what we have here, 2 to the power of x. We have to factor out 2 to the power of x from here and here, since it's common to both quantities. So from here, we now have here 2 to the power of x bracket. If we use this to divide this, we are left with our 4, then minus. We use this to divide this, we are left with 1, close bracket, everything equal to R4. Here we are having 4 minus 1, right? So we can carry out our subtraction. And if we do that, this is going to give us our 2 to the power of x, then into our 3, then equal to our 4. Let's continue on this side. Okay, mind you, we are looking for x. So the best thing to do here is to eliminate this 3 here. We divide through by 3. So we have 2 to the power of x times our 3 all over 3 equal to our 4, right? All over our 3. This will leave. So we now have 2 to the power of x is equal to 4 all over 3. Okay. Now, from here, we just have to eliminate both sides of the equation. Okay? So our 2 to the power of x is greater than 0, or must be greater than 0, right? So we have here 2 to the power of x is greater than 0. So if it is so, then we cannot have a negative value from this expression here. Okay, so we're going to ln both sides of the equation. So we have the ln of 2 to the power of x is equals to the ln of 4 all over 3. Let's put this in bracket. Wow. Here we have the power here. So we're going to apply the power law of logarithm, and we're going to apply the division law of logarithm too. The power law says that when you have the ln of your a to b to the power of b, we have to move this to this side to give us our b times the ln of a. Then the division law for this other side says that when you have the ln of your, this ln please, the ln of your a all over b, this is equal to the ln of a minus the ln of b. So let's apply these two rules here. So we're going to move this to this side. So we have our x times the ln of 2. This is equal to, here we're going to have the ln of our 4 minus the ln of 3. Easy. Because we have ln of 2 here, and we can express 4 as 2 to the power of 2, then we just have to rewrite this. So this is going to give us our s times the ln of 2 is equal to the ln of 2 to the power of 2 minus the ln of 3. Easy. All right. Again, we apply the power law to this to give us x times the ln of 2 is equals to 2 times the ln of 2 minus the ln of 3. All right. Now, we are looking for s, so we divide by the ln of 2. So we divide by ln of 2, we divide everything here by ln of 2. So this leaves the system. We now have our x will now be equal to, we can rewrite this expression we have here now. This is the same thing as our 2 times the ln of 2 all over the ln of 2, then minus ln of 3 all over the ln of 2. This expression here is same thing with what we have in here now. These are common, so this and this will leave the system, right? So we are now having our x standing on its own. So we now have our x, therefore will now be equal to 2 minus the ln of 3 all over the ln of 2. So we can get the numerical value for the ln of 3 and that of 2. So the ln of 3 is 1.099, and that of ln of 2 will give us 0.6931. So rewriting this, we're going to have our x is equals to 2 minus our 1.092 all over 0.693, right? Okay, so 3,1. So let's put it here to, okay, 3,1. So we can easily divide that, and if we divide that, will give us 1.586. So we have our x is equals to 2 minus 1.586. Easy. What if we subtract this now? What will this give us? It's going to give us 0.414. So we have, therefore, our x is equals to 0.414. So this is the value of x that will actually satisfy this original equation. But if you input these values into this system, you're going to have what is called the approximate value. Not exact values, but it's an approximate value, very, very close to each other. All right. Now, this brings us to the end of this math class. Thank you for being there. See you in our next class. Bye for now.